purpose of this experiment is to determine the volume 1 mole of hydrogen gas has at standard temperature and pressure. Now we're going to achieve this by reacting magnesium metal with hydrochloric acid, which will then produce hydrogen gas as a product. We will measure the amount of magnesium we want by putting it on a scale and determining how many grams we have, and we're going to submerge that in excess hydrochloric acid. So the amount of hydrochloric acid really doesn't matter in this experiment, since it's meant to react completely with all the magnesium. Now the product is going to be hydrogen gas, which will then fill up this chamber. This is an Erlenmeyer flask, which will have to determine the volume of the entire flask in order to determine the volume of the gas being produced. Then we will essentially look at the pressures building up inside this chamber. And with all that information and the temperature at which the experiment was ran, we can then determine the conditions at standard temperature and pressure and figure out the volume of gas we would have at standard temperature and pressure. We would then also have to consider the moles of hydrogen gas produced in this experiment and divide that by the volume at standard temperature and pressure, which would then give us the molar volume, which essentially is the volume of 1 mole of that gas at standard temperature and pressure. Now, ideally, our goal is to achieve 22.4 liters, which is essentially equal to 1 mole of any gas at standard temperature and pressure. Now, for this experiment, we're going to consider multiple trials, and we're going to consider the average of the changes, the average temperature in all different trials, as well as the average mass for the magnesium in this experiment. And that will help us determine the closest molar volume of hydrogen gas. Good luck.